Hello everyone, my name is Parth Patel and this presentation is all about the preparation of the epoxide using the urea based solid amide catalyst, and I am from Central Salt and Marine Chemical Research Institute as a research scholar from Bhavnagar, Gujarat. This presentation consists of different sections, and first we'll go with the introduction, why the epoxides are important, and then we will move on to the literature survey about the research that has been done for the synthesis of different epoxides, and basically what problem of epoxidation reaction is. We will talk about that, and then moving on to the catalyst preparation, our methodology that we have adopted for the synthesis of the solid amide based catalyst, and then we will move on to the substrate scope, wherein different substituents based styrene or the internal olefins have been realized for the synthesis of the epoxide, and then moving on to the catalyst recycling and the conclusion part. The background of the epoxidation reaction. The dominant epoxides industrially are ethylene oxides and propylene oxide, which are produced respectively on the scales approximately between 15 and 3 million tons per year. And these are basically the ethers having the oxygen atom in a three-member ring, and commonly also called as oxyranes, and it is a special type of ether, and the COC bond angle for the epoxidized must be 60 degree, a considerable deviation from the tetrahedral bond angle, that is 109, sorry, 109.5 degree. Thus epoxides have angle strain, making them more reactive than the others. The introduction part. The alkene epoxidation is one of the important area of the research, wherein these epoxides have wide application in the industries and the academics. Particularly, they are the building blocks of various organic reactions, and they are used as a plasticizer. And the main use of these epoxides is in the perfumery industries as fragrance and flavors. So when an alkene is converted to a to an epoxide, these epoxides uh, are what you call is the feed for the fine chemicals, and for example, these styrene oxide can be converted to the diols. This is styrene oxide in the presence of any amine, any nucleophilic attack by the amines, it can give the amino alcohols. So this particular compound has its own importance for the conversion of the different fine chemicals in the industries. As this particular reaction is very important, so various research groups have worked out in this area. In the year 2000, one of the research group, they have used oxone as a oxygen precursor to convert the styrene compound into the styrene oxide in the presence of copper as a catalyst. But the main drawback was using use of the oxone as a toxic reagent, and the benzaldehyde was the side product which was not needed, and this was basically the drawback of this particular reaction. And we have also used urea as a catalyst in the presence of sodium bicarbonate and manganese sulfate as a S2O2 activator in the presence of water to convert the styrene into the styrene oxide. And in the year 2014, another group, they have used the trifluoroacetophenone as an activator for the conversion of the alkenes to the epoxides using acetonitrile butanol as a solvent. But the use of the trifluoroacetophenone makes it less viable. Continuing the literature surveys, and And in the year back in the year 90s, research group they have used the perbenzoic acid to convert the styrene into the styrene oxide, and then further improvement was done using silver as a heterogeneous based catalyst, and converting the styrene to the styrene oxide. And then again, one of the group they worked in this area, and they have used potassium carbonate, DCC, and H2O2 as a reagent to convert these epoxides. Though much of the work has been done in this area of the epoxidation, however, there are shortcomings with this reaction. There are limitations for the reactions with different research groups. The main problem of the epoxidation reaction is the oxidation of alkenes using the per acids, that is meta perbenzoic acid in the stoichiometric amount. And with this, by using this stoichiometric amount of this acid, the major problem comes out with the process of the waste generated, which is not environment friendly and is not economically viable. And also use of the different oxides like cobalt oxide also converts these metal oxides also convert the styrene, or that is the alkenes, to the various epoxides. However, limitations lies even in that. And these metal oxides like nickel oxide, cobalt oxide, molybdenum oxide, and the copper oxide, it has also been reported for the epoxidation of the styrene using the tertiary butyl hydrogen peroxide as an oxidant. But these catalytic systems decomposes because hydrogen peroxide is highly reactive. So in the present invention, what we thought of is inventing a system wherein uh, we can recycle the catalyst, and the whole process is the user friendly, that is the environment friendly, and no toxic metals are used, and this reaction can work at the ambient temperature to get the high conversion and the good selectivity, and the catalyst can be recyclable with a number of times. So keeping this view in mind, we prepared the solid based amide catalyst. The catalyst preparation is very simple. As we know that the cyanuric chloride, it has the three different chlorine atoms, and they are reactive at different temperatures. One chlorine atom can easily be removed at the ambient temperature, and a slight heat is given, that is between 50 to 60 degree. Second chlorine atom can be easily removed. However, third chlorine atom requires high temperature, but still it can be removed. So you keeping in view of the reactivity of this triazine moiety, we thought that if the urea, which what we used earlier as an eco-friendly method, if this urea moiety can be uh, coordinated or can be reacted with the cyanuric chloride, there is a possibility that we can get the dendrimer type of catalyst. So the method was very simple, and it was the cyanuric chloride was 1 weight percent was taken, and 6 weight percent of the urea was taken, and it was simply refluxed. It was simply heated for 3 hours. Whatever the HCl was generated, it was the fuming HCl, and it was completely removed. And once the catalyst was prepared, the HCl, remaining HCl was removed, and the urea was removed by simply washing with the water to get the solid compound for what we call is the urea based solid amide catalyst based on the triazine linker. The catalyst was prepared, and it was also characterized with different spectroscopic techniques, and then it was realized for the catalytic activity of the epoxidation of the different alkenes. And in this particular reaction, base was used as reported earlier. Manganese sulfate was used to activate the hydrogen peroxide, and this reaction proceeded smoothly at ambient temperature. And different aromatic and the aliphatic alkenes have been studied for this particular epoxidation reaction, and different substrates with different substituents gave good conversion and selectivity of respective epoxides. Slow addition of epoxide is essential for this particular reaction, because early and the fast addition of hydrogen peroxide leads to the formation of the side product and decreases the selectivity with incomplete reaction. And manganese sulfate is used as an additive for the oxidation of the hydrogen peroxide. And apart from these alkenes, alpha pine oxide is also demanding molecule. So we thought of using this particular catalyst to check its activity. However, the selectivity was less than 80% in the optimized conditions for the olefins, but alpha pinene was tried. The epoxide of the alpha pinene was tried with the another suitable oxidant. It gave good results not with the hydrogen peroxide but with the metachloroperbenzoic acid as an oxidant at a little lower temperature, that is a 15 degree, and we got good conversion and the selectivity in 7 hours. Different substrates worked well with this particular epoxides, for all the cases like electron withdrawing and electron releasing group, and also for the chromium oxide and different substituted groups of the olefins. It gave better results, almost up to 99% of yield as well as the selectivity. However, it also worked for the aliphatic alkenes like propylene, and it also converted to the propylene oxide in the high selectivity, that is the 96% to 99%. However, when the alkene chain was increased, the reactivity was decreased. So what we confirm from this is that aliphatic alkenes worked well only with having only with a short chain. Though much of the work has been done in this area of the epoxidation, however, there are shortcomings with this reaction. There are limitations for the reactions with different research groups. The main problem of the epoxidation reaction is the oxidation of alkenes using the peracids, that is metaperbenzoic acid, in the stoichiometric amount. And by using this stoichiometric amount of this acid, the major problem comes out with the process of the waste generated, which is not environment friendly and is not economically viable. And these metal oxides like nickel oxide, cobalt oxide, molybdenum oxide, and the copper oxide, it has also been reported for the epoxidation of the styrene using tertiary butyl hydrogen peroxide as an oxidant. But these catalytic systems decomposes because hydrogen peroxide is highly reactive. So in the present invention, what we thought of is inventing a system wherein we can recycle the catalyst, and the whole process is the user friendly, that is the environment friendly, and no toxic metals are used, and this reaction can work at the ambient